Okay, so today it is 2.3. We're talking about statements, conditionals, and biconditionals. Okay, so a statement is something that could be true or false. Okay, a conditional specifically if then, and biconditional, we'll get to that in a minute. Okay, so statement, a sentence that is either true or false. Okay, and so dogs have sharp teeth. Could be true or false. Okay, pretty sure that's true. You may have a counterexample like, no, not all dogs do. This kind of breed does not. Okay. Or what if they don't have teeth? Okay. That could be true. Okay. And so sometimes we use a letter to talk about a statement. Okay. So like P. Okay. Dogs have sharp teeth. Um, Negation would be that we can do the opposite. Okay. And so we don't really focus on that in this class. So negation means opposite. Um, and so um, dogs don't have sharp teeth. Okay, well, that would be the opposite and has the opposite truth value. Okay, that could be true or false. And if this right here is true, this will be false. Okay, and if this right here happens to be false, because they're like, no, they don't all have sharp teeth, then this would be true. Okay, so negation would be the opposite. Okay, truth value. Is it true or false? Okay, so is your statement true or false? Okay, and even if you can come up with one counterexample, one thing that says, hey, look, it's not true, then it's false. Okay. If it's only 99% true, it's still false. Okay. So that's kind of that's the truth of that as well. Okay. Counterexample would be say that you make a statement. You say, hey, everybody will like the South is nice. If you can come up with one counterexample, you're like, no, look at this one girl. She is very mean. She punched somebody in the face. Okay. Well, guess what? Not everybody is nice. So that's a counterexample. Everyone in Olathe South always wears um, leggings or jeans, or, like everybody always has blue and yellow on every day. You're like, no, here's an example of someone who doesn't. Okay. Well, then that shows it's not always true. So it's false. And so you can read it. Counterexample is that it is an example where it's not always true. Okay. Um, just one counterexample can show that it's false. Okay. So a compound statement. If you have a compound fracture, I hope you have not. Okay. I had a student tell me the other day about a compound fracture, but their grandpa fell out of a tree. And so the truth is, not only did he break his femur, the bone in his leg, but also is sticking out of his leg. Okay. So a compound fracture means it's got two problems. A compound statement has two things. It could be and or. A compound statement, a conjunction, okay, con in Espanol means with and. And so if you have a square, then you have to have four congruent sides, four sides that are equal, and four right angles. If you just had four right angles, you might just have a rectangle. But if you're going to have a square, you have to have four congruent sides, four sides that are equal length, and four right angles. Otherwise, it's not going to be a square. Okay. The two things and one thing and the other have to be true. Otherwise, it is not done. Okay. Now, or means one or the other or both. Okay. So if you're going to be at Olathe South, you could be a student, or you could be an employee, or you could get paid for being a student. You could be both. Okay. So one or the other or both. Um, pardon me. Okay. So if you have, okay, a conditional statement, okay, let's talk about this. A conditional statement, what are the conditions? Well, the conditions are a hypothesis and then a conclusion. If P, then Q. Okay. Your mom probably has told you this for years. If you eat your dinner, well, then you can have dessert. If you do your chores, then you can go hang out with your friends. Okay. If you have a conditional statement, it's the conditions for it to work. If you do a good job at work and you are on time, then you're going to get paid. Okay. So, a conditional statement has a hypothesis and a conclusion, and then it can be written as an if then statement. Okay. Again, we can't prove your conditional is true just by giving examples of it, but just one counterexample can show that it's false. Okay, so here is the example of a conditional statement. Okay, here we go. Wait, so we're just restating what our definitions are. Okay, and conditional statements, they provide the logical structure. And they're going to help us when we do deductive, like the logical lawyer-like proof type situation. They're like, hey, therefore my client is not guilty. And also you should pay him $1 million, etc. So if P then Q, this is how you write it. If P then Q looks like this. Okay, so if you have P, if you're in P, you're automatically in Q. Okay, so if P happens, then Q follows. So the if part is called the hypothesis. Okay, so like if you eat your dinner. Okay, now it actually doesn't use the word if. You have to remember, don't use the part of the word that's if. Okay, so eat your dinner. Okay, the word if is not part of the hypothesis. So the part just after the word if is the hypothesis. Eat your dinner. And I can write that. Eat your dinner. What will follow? Dessert. Okay. So the conclusion is what happens as a result. Then what happens? Okay. It follows the word then. Okay. So it does not include the word if, and it does not include the word then. Okay. Okay. So what is the hypothesis? Eat your dinner. What's the conclusion? You'll get dessert. Okay. And then let's talk about this here. If you take a class in TV broadcasting, then you'll be able to film a sporting event. So let's practice doing this. So if your hypothesis will make that green, okay, the if part. Again, the part that just follows the if. Conclusion is the result that happens, okay? Conclusion is kind of the end, okay? So the if part is this. If you take a class in TV broadcasting. So take a class in broadcasting. Then what happens? Well, what happens is you will form a sporting event. Okay. Class leads to filming. Okay, so I'm just kind of showing it visually. Okay. The if part is the hypothesis, and the conclusion is the result that happens as a result. Okay. The next one. Okay. And sometimes they're a little bit weird as to like which one comes first. Okay. If there is not a specific if in the thing. And so this one right here, if I wear my jacket, then it's cold outside. Okay. So we could probably talk about it the other way, because the other way is probably true. So if I wear my jacket, okay, not the if part, but I wear my jacket, what does that mean? It's cold outside. Okay, so wearing my jacket implies that it's cold outside. Okay, and then the next one is a polygon is a triangle if it has 3 sides. Okay, and so let's look at this. What is the first thing? If it has 3 sides, then what? Then it's a polygon, is a triangle. So the 3 sides implies that it's a triangle. Okay. All right. So here we go. If you have a spider, do you automatically have a tarantula? No. Okay. So if you have a tarantula, okay, so the tarantula is the hypothesis. Okay. You start with the tarantula. What do you automatically have? Well, that means you have a spider. Okay. It's a big spider. It's horrible. Okay. So tarantula means you have a spider. The other way is not true. If you have a spider, you automatically have a tarantula. No. Okay. The next one. And any of these could be true or false, but we're trying to say, can you hear the hypothesis, which is the part that follows the if? Can you hear the conclusion, which is the part that follows the then? Okay, so what's the if part here? Can you write this in if then form? Okay, so let's do this. So I could see this be written a couple ways. And I would say I'm not going to be mad at you if you kind of write it one of 2 ways. Okay, so if you have an umbrella, then it is rain outside. That'd be a good way. If it's rain outside, then you have an umbrella. That's an option too. So I could see either way. So if you have an umbrella, then it's raining outside. Okay. The if part is the hypothesis. You have an umbrella. Okay. So the hypothesis would be you have an umbrella. Then what does that mean as the result? Raining outside. Okay. So that follows. Having an umbrella implies it's raining outside. Okay. And that's not always true, but that's going to be an if-then statement that you could write. Okay. And conditions are if-thens. Okay. As a hypothesis, start with this, then this will follow. Okay. Angles that share a common vertex and a common side. Okay. Oh, adjacent angles. It's underneath my little thing. Okay. So if angles are adjacent, then what? Common vertex and common side. Okay. So the if part is the hypothesis, angles are adjacent. If you have adjacent angles, okay, so angles are adjacent, result would be common vertex and common side. Oh, that should be purple, shouldn't it? Pretend that's purple. That's the conclusion. Okay. So writing it as if then you include it. But if I ask you what's the hypothesis, you say what is the part that is the beginning, okay, the if part, not including the word if, and the conclusion would be the part that's the result, okay, not including the word then. Okay, good. So next part, let's turn the page. Okay, and on the back, we're going to talk about are things true or false? Okay. And again, you can't, if you have an if then statement, you can never prove that it's true, okay, by just showing a bunch of examples. Okay. What you can do though is say, I've got a bunch of examples that show it, but if you happen to find a non-example or a counterexample, then you can show it's not true. Okay, so let's do this here. It says determine the truth value. Is it true or false? Okay. And if it's true, explain your reasoning. If it's false, give a counterexample. Tell me why you think it's the case. Okay. So the hypothesis, we'll start with green. A and B are negative numbers. Then what's the result? Okay. The conclusion would be that means that A plus B is also negative. Okay. Let's try that. You've got like -3 and -2. Okay. And you're going to plus them. Okay. Same sign add keep. So -3 and -2 equals -5. Okay. If you come up with any two negative numbers and you take them added together, guess what? Your answer will be negative. Okay. And so, um, so here's some examples. Okay. See examples. Okay, so, and you could say, adding two more negatives together, make it even more negative. Okay, -3 and -8, make it -11. Okay, and so, probably not see examples. Okay, adding to negatives makes some more negative. Okay, -2 and -3 makes -5. Okay, so, all right, if an angle is an acute angle, so the hypothesis would be an acute angle. The conclusion would be the angle must be 35 degrees. Okay, is that true or false? Even if it's like sometimes true, doesn't mean it's true. Okay, can you think of a non-example? You could say, um, 40 degrees. And acute angle could be 40 degrees. Okay, or you could say it's any degree that's less than 90. Okay, so between 0 up to 90. Okay, so given a counterexample. Okay, so telling if it's true or false, talking about what the hypothesis and the conclusion are, talking about if-then statements. Those are all good vocab things. Converse. Did you know, okay, that the Converse shoes were really innovative for their time? Like if you Google the history of Converse, they're shaking things up. Okay, back in the olden days, when people played basketball, they were on the court in not the things that you guys wear out playing basketball. Tennis shoes were really an invention that happened within at least my parents' lifespan. Okay, and so the thing is, Converse shakes things up. It basically exchanges the hypothesis and the conclusion. Okay, so think about this. You know, in general, your parents are like, if you eat dinner, then you get dessert. What if they switched it up and they said, if you eat dessert, then you get dinner? That's kind of weird. Okay. So if you switch it, now that may or may not be true. Okay. So here's an example. Okay. This is your statement right here. Okay. And this right here would be the converse. Somebody's driving by in a really cool car. If you can hear it, that's kind of crazy. Okay, here we go. Okay. If an angle is a right angle, then what happens? Okay. And I shouldn't highlight the if part, but okay. An angle is a right angle. That's the hypothesis. Then what follows? It's got to be a right angle. And that's 90 degrees. Okay. If you do the converse, you switch the ifs and then so notice P goes to Q. Well, if you do Q goes to P, you flip them around. You say, if you got an angle that measures 90 degrees, okay, and that would be the hypothesis, then the conclusion would be, then it is a right angle. Is that true? Yeah, they're both true. Okay, so we're going to talk about, you got a statement and if then statement, okay, and then switch it around and do the converse, switch the ifs and the thens, okay, and then we can talk about how many of those are true. Okay, so here's your conditional statement right here. So conditional, okay, your if then conditional statement. Okay, conditions could be like if you eat dinner, then you get dessert. So if, okay, if your angle is 95 degrees, and I should have a degree symbol on there, I'm not sure where it went, then, okay, your result is, then it's got to be an obtuse angle. Is that true or false? That's true. Okay, if you've got a 95-degree angle, well then, yes, absolutely, it is going to be an obtuse angle. Okay, so the next thing is, okay, let's do the converse of that one. How would you write that? If you have an obtuse angle, then the measure of angle A is 95 degrees. Is that true? No. Okay. Just because you have an obtuse angle, does that mean that it's 95 degrees? No. Okay. It could be 100 degrees. Okay. Just because you have an obtuse angle doesn't mean that it's 95 degrees. Okay. So converses could be true or false. Okay. So let's just kind of think about it. You just switch the ifs and the then. Okay. Let's try another one. If you have a hamster, okay, then you have a rodent, okay? So let's write the condition. If you have a hamster, then you have a rodent. My handwriting is getting worse, okay? Is that true? Yeah, that's true. Okay, if you have a hamster, then you have a rodent. Okay, hamsters are rodents for sure. Okay, what if you do the converse? If you have a rodent, then you have a hamster. That is false. Guess what? Caught a my cat has caught a mouse in our house. Okay. Does that mean we had no, we had a rodent in our house. Our cat caught it, but that was not a hamster. Okay. Unfortunately. Okay. And so that is false. Okay. So the truth is this: by means to, right? Okay. Biconditional. So biconditional is when you play with the order. Okay. And you talk about, hey, my conditional is going to be if P then Q. The converse is instead of doing if P then Q, you switch the order and you do if Q then P. Okay. You switch the order. And the truth is that biconditional means, hey, can it be true both ways? Okay. So what you do is this, okay, to write the biconditional, okay, you start with the conditional, okay, where it says, if you have a right angle, okay, then it measures 90 degrees, right? What you do is you do the exact same order as that one, okay? Okay, because conditional and biconditional are the same order. But what you do is this, you take the if from in front of it, okay? So there's no if here. Okay, you don't put it there, you put it between here. You say if and only if. Okay, so this is kind of a weird thing. And the way you do it is, so you don't have to write so many words, is IFF. It means a shortcut word for if and only if. Okay, and that means if you use it this way, it means it's true both directions. If you, an angle is a right angle, if it measures 90 degrees, and it's also true, if it's true both ways, it's going to be true for this. If it measures 90 degrees, it also is a right angle. So if it's true both directions, then you put this right here that says, hey, if you have P, then Q happens. If you have Q, then P happens. It says either way, it's going to mean the same thing. Okay, they go together. They can't be separated. It is a true biconditional statement. So sometimes I'll have you write them and be like, is that true? And if these two are both not true, well, then this won't be true. Okay. But if this is true down here, well, then those will all be true as well. So if and only if is mostly used if it's true both ways. Okay. It's true both directions. Okay. So let's check this out. So let's talk about biconditional. So if your conditional states that if you have points on the same line, then they must be collinear. Is that true or false? If you got points on the same line, will they be collinear? Yeah. Okay. That's true. Okay. The converse of that is if you have collinear points, okay? Sometimes you have to move the noun up a little bit. If you have collinear points, then they are on the same line. If you have collinear points, will they all be on the same line? Well, that's also true. So guess what's going to be true? It's true both directions. It's true if they are on the same line, they're collinear. If they're collinear, then they're on the same line. Like a biconditional, again, you go back to the conditional, you use that order, okay? You say points lie on the same line. If and only if, the if and only if goes in the middle. You can either write if and only if or IFF. And then you say they are collinear. And since it's true, both the conditional and the converse, well, then the biconditional will also be true. It's true both directions, this to here or that backwards, okay? So let's try the next one. An angle is obtuse, okay? If and only if the measure is between 90 and 180 degrees. Okay, that's the biconditional. Okay, and so what they want you to do is to write the conditional and the converse from that. So conditional is the same as the biconditional. Okay, this is the bi. So the conditional will be the same. So if an angle is obtuse, then it is between 90 and 180 degrees. Okay, and that's true. And the converse is going to be if an angle, again, sometimes you have to move the noun up there. If the angle is between 90 and 180, it is obtuse. And that's also true. Okay. So guess what? All three are true. Okay. If it's only true one way, then it is the biconditional will not be true. So here's an example. If you, let's see. If you have a square, then all four sides are congruent. Okay. If you have a shape with all four sides congruent, then it must be a square. Is that true? And the answer is no. You could have a rhombus. A rhombus is this. All four sides are congruent, but it's squished. It doesn't have right angles. Okay. So just because you have four congruent sides doesn't mean that you have a square. Okay. So if you have a square, then you have four congruent sides, but just because you have four congruent sides doesn't mean that you have a square. So if it's not true both ways, the biconditional will not be true. I may still ask you to write it, but it will not be true. All right. Well, this will be good for us to practice on. I'll give you some homework for you guys to work on. Thank you so much. I hope you guys have a wonderful day.